All right. So we're rolling again. All right, any questions?
I have a question. So on, oh gosh, this is gonna go a long way back. Test 1A, or wait, yeah,
Okay.
1A, question 1F, not a short answer. It's like calculating the total distance traveled,
Right.
and I tried to look for that when doing my test corrections, and I could only find people talking about displacement, which I had already done previously. I just wanted to ask, like, how do you do distance traveled?
Carefully. And I don't want to bury that. All right, so the key thing is that in those type problems, I have an object turning around
Yeah.
at a constant acceleration. The acceleration is constant, so I guess a dot is equal to 0. So I'm starting at some location, I go in a particular direction, I turn around, and I come back, and I end up on one side or the other of my starting point. So if to the right is positive, and this is a rather pungent marker. So this would have a negative displacement, so if you plugged into just the Kate formulas with the information, you'd get a negative number, and presumably you've already gotten that previously.
Yeah.
So let's just say, for example, you have a displacement of negative 50 meters.
Yeah.
The distance traveled is basically the actual distance. I went to the right a certain distance, and then I came back a certain distance. Well, if I went to the right, let's just say 100 meters, that means it took me 100 meters to get back to my starting point, and then I end up 50 meters to the left of it. So the total distance I traveled was 100 meters plus 100 meters plus 50. 250 meters.
Okay, so when I was looking it up, some of the like things I looked at like talked about integrals. Is that like do I have to?
Wow. If you want to bring calculus into it, you can, but that is making it way more
So
complicated.
that's like not what we had to do there.
Correct.
All right.
If acceleration is constant, then calculus is just for your own personal pleasure.
Okay. Gotcha.
Afterwards, if you have a specific question, we can talk more one-on-one.
Okay.
Unless someone else has another question about this.
Is
But-
this the test correction?
Pardon?
Is this the test correction?
Yeah.
Yeah, that's
Oh,
one.
okay.
So the trick is to figure out how far you go before you stop. And I think there's a previous question was, you know how much time it took. You know the initial speed, you know the final speed is 0 here.
There was like a question like when does it stop? You know, I guess we just use that.
Yeah, use that number, that should be very helpful in getting how far it goes to the right.
Okay.
Other questions? Will and Pat?
Same question section on the test corrections. What is the difference between average velocity and average speed?
Average velocity is displacement over time.
Okay.
Average speed is distance over time.
Yeah, I figured out that if I wanted to do the speed one, I had to figure out the distance
Yeah.
traveled one.
So in this particular case right here, my displacement, nice green, is negative 50 meters. My distance traveled is 250 meters. So if the whole thing took place in 10 seconds, my average velocity is negative 50 meters divided by 10 seconds, or negative 5 meters per second. My average speed is 250 meters over 10 seconds, or 25 meters per second.
Okay.
They did. very similar example of, this morning I started out at home, I come to school, I'm gonna go back and put the car pretty much in the same spot it was when I left. So my average velocity for the day will be 0. My average speed will probably be about 30 miles an hour. And remember that I can match Usain Bolt with average velocity. I cannot match him with average speed, unless he's walking and I'm running. Other questions? Oh, that's right, Matt.
Yeah, so, this is mostly about force, some force questions. So for, on master set, 8, for problem 3, I don't know if I'm overthinking this, but it's more about the relationship between, the force with velocity versus time, and then the force with kinetic energy versus time. Cause I put the scenarios all in the same place for both, and I was like, that can't be right.
There's a trick there. All right, so let's say that my velocity is 5 meters per second, and I've got a mass of, like 10 kilograms. What's my kinetic energy?
Uh, 125K.
125 what?
Joules.
Okay. Suppose instead my velocity is negative 5 meters per second. What's my kinetic energy?
125, because it's v squared. That's what I figured out yesterday, because I looked it up and it was like kinetic energy has to do with like the velocity squared.
Technically, it's the speed squared,
Yeah.
but, you know, squaring negative 5 and squaring 5 get you to the same place.
Yeah.
So we can assign multiple scenarios to one line on a graph?
Yes.
Yeah.
Okay, yeah.
Because I figured out that like 2 of those lines just weren't used.
Unfortunate. And that's, I'm assuming this is for the kinetic energy versus time, and the velocity versus time, that's independent
Right,
of what this is. We're talking about the kinetic energy
right,
versus time
yeah, the
graph.
kinetic energy, that, yes.
And then, I also, while I was doing some of the problems, I have a really hard time identifying, especially with, mostly with like displacement or with height, how I can just make a value 0 and then stick with that for the rest of the problem. In terms of when you're doing like with a conservative force, and when does it end up, where, like what's the final displacement, or like with springs, like how far in the spring, when the object is like dropped, like how far does the spring compress? I just always had a trouble identifying like a 0 for the displacement part. Like I know the velocity and stuff, you can get those to 0, but yeah, that's my question. How do I identify that? Or how
So
do
when you're dealing with a spring, it's just simplest to let 0 be the equilibrium spot. Even though I did work through a problem, I think I made the video and posted it, where I established 0 as not the equilibrium spot and showed that it didn't matter, it came out with the same answer. But for springs, if you let 0 be the equilibrium spot, life is just a whole lot simpler.
And so essentially if I don't make any of those values 0, but I keep them constant with each other in terms of like the differences in value,
Yes.
then I should get the same answer?
Yes, you
It'll
should.
just be more work for me?
Yes. I mean, it's, a good deal of physics is trying to find a reference frame where you simplify the math as much as possible. Because this was all developed pre-computers. So they're looking for any way to make it life easier.
sorry. That was a couple questions. Oh, when, for master set 9, it's talking about, the, just to clarify, that the work can be negative.
Yes,
Okay, and then also, it was number 3, and it gives a force in I hat, J hat, and K hat. But it only gives the intervals for I hat. Does that mean we only use the I hat forces for the whole problem?
because when you're finding work, that force was constant in that problem, right? Or did it vary?
Yes, a sole force, yeah.
No, not, is it?
And it's like, yeah, it is constant. It's 1 I hat plus 4 J hat plus minus 2 K hat.
That's the initial position, so.
Oh, sorry,
Yeah, sole force,
my
okay.
bad.
Well, actually, let's go ahead and. So it's a dot product between force and displacement. If the force is constant, it would come out, and this just becomes F dot delta X or R or whatever letter you happen to be using. When you're dealing with a dot product, you are multiplying components that are in the same direction. So if I have an object that's only moving in the X direction, then the only force that's gonna be doing any work, or only part of the force, is the force in that same direction. Or parallel or anti-parallel to it.
So, if it gives the intervals in like I hat, then you only use the component of the force that, or the component of the, the component of the force that is I hat.
Yes, and let's make it, just, I think this is going over exactly what you just said. So if I have 5 I hat plus 3 J hat, dot product with negative 2 J hat, there's an implied 0 I hat. But I would just multiply the I hat component, so it's 5 times 0, plus 3 times negative 2. So negative 6.
Sorry, just looking, I put like stars, you know, like, I had a question.
And matter of fact, if, I'm gonna take this one step further. This would be 0. Because this has no parts that are parallel to this, because this is K hat. So that equals 0.
Okay,
And dot product therefore is actually a way of determining perpendicular. If I have 2 vectors and I wanna know if they're perpendicular, I can do a dot product. If it's equal to 0, they're perpendicular. Alright, so Pat, you're about to ask another question?
I'm still looking
Okay.
if I do have another question, so sorry,
PJ.
anything.
On master set 8, if it's on a ramp, is the kinetic energy still 1/2 mv squared, or is it different?
Kinetic energy is 1/2 mv squared.
Okay, so even if it's on a ramp, it's still that?
Yeah,
Okay.
it is one of the few formulas that don't change as you get into more and more advanced physics.
Can you go over what the dot product means? Like when you have the dot there, I forgot about that.
Dot product means that, again, 2 ways of multiplying vectors. You got the dot product and the cross product.
Okay.
Dot product represented by a dot, cross product represented by, looks like an X, but
Yeah.
it's called a cross. This is also known as a scalar product because the answer is a scalar. This is known as a vector product.
Okay.
And to be pedantic, it actually produces what's called an axial vector or a pseudo-vector, not technically a vector, but in 251 and 250, matter of fact, until you get into graduate level physics, it looks, smells, and tastes exactly like the same vectors we've been dealing with.
Okay.
And then this is also the inner product and outer product. That's what gave you So these are different names for the exact same thing. Big thing here, dot product multiplies parallels. Multiply parallel. Cross products multiply perpendicular.
And that's what I'm confused on, what does that mean exactly? Like perpendicular and parallel? Oh, wait, with the vectors, like when you're looking at them?
Yeah, so if I've got some vector A here and a vector B here,
Yeah,
I can break B up into its components.
yeah. So you have, yeah,
If I'm doing a dot product, I'm multiplying that length times that length. If I'm doing a cross product, I'm multiplying that length times that length.
okay, yeah, alright, gotcha.
And when we get to rotational motion, the cross product will come in more than we've done it already.
So, sorry, I found, when I was saying, when I was talking about the intervals, I was mistakenly saying that was 3, it was actually 4, my mistake. And, it's not a constant force, and so, I found the total work within I hat and J hat, but the intervals are in I hat. So do you take the integral with the intervals, you only take the integral of the I hat?
Yes.
Okay,
Yeah, technically, you do the dot product first, which would eliminate, if it's only moving in the I hat direction, the dot product would get rid of the J and K hat parts. And you'd only be left with the I hat parts.
well, no, it's actually, it's moving in I hat, J hat, and K hat.
But the force is only in I hat, right?
No, the forces, the forces are in I hat, J hat, and K hat as well. The only reason it says, I put, I was curious because it's, the intervals say
Right.
that they're in I hat.
If, I'll use a marker here. If, in this particular case, I'm asking for what's the final speed of
Yes.
these. Speed is related to what energy?
Kinetic.
All right, so what is the work energy formula which uses kinetic energy?
Total work,
Is that equal?
change of kinetic energy.
All right, total work is the integral of the total force dot d, whatever letter you happen to be using, is equal to k final minus k initial. The total force, yeah, there is movement in the j hat direction, but the total, if you look at the total force, the j hat and the k hat components drop out. Total force, add them together.
Oh, I see what you're saying in this equation.
So my total force is only an I hat component, therefore I only care about, and so dr is, like dx I hat plus dy j hat plus dz k hat, using standard brainwashed directions. So I'm doing a dot product here. And since this only has the I hat component, these don't contribute anything. There's bizarre notation there. Oh, that's a Y. That's a plus. Okay. So I made the problem look more complicated than it is, but it ultimately breaks down to, I'm only doing changes in the I hat direction.
Gotcha.
And I am asking for the final speed, not the final velocity.
Yeah.
Okay. And speaking of which, suppose my initial velocity, or suppose I have a velocity of 5 I hat minus 2 j hat plus 3 k hat meters per second. How would you find the speed?
Do you take out the direction, like take out the direction components and then just add it together? Just guessing.
Please don't. Please don't. He was just joking about that. Hey, he's here all week. Don't forget to tip your waiters.
Is this where you square it, take square root?
Yeah. If it were two-dimensional, let's just ignore the k hat part. If it's two-dimensional, that means I'm, again, going in the traditional I hat, j hat. I'm going 5 in the I hat direction, j in the negative k hat direction. And so my speed is basically the hypotenuse. So I'm doing Pythagorean theorem. But in a three-dimensional problem, 5 squared plus 2 squared plus 3 squared. Or for those purists, negative 2 squared.
Oh, so just the magnitude of it.
Yeah. You can also look at this. Going back to the dot products. If I want to know what my speed is, well, if I do a dot product with itself, well, just think about that. V is just, again, brainwashed. Vx I hat plus Vy j hat plus Vz k hat. Dot product with itself, well, the I hat components multiply together, and so I get Vx squared plus Vy squared plus Vz squared, and that's just equal to my speed squared. So a vector dot product with itself is basically the scalar square, which connects back to the other definition of dot products. By A dot B, it's A times B, that's the magnitudes. Let's go for the formality. The magnitude of A times the magnitude of B times the cosine of the angle between them.